I'm Bill Kinney from Bethel University, and this is video number 11 in my series on the foundations of arithmetic, algebra, and graphing. I'm subtitling this a first peek at algebra, subtraction and division as inverse operations, and I intend for this video to close out what you might call the first block of videos, which are focused on operations, arithmetic of integers, applications of integers, and that kind of thing. Going to consider two problems in this video. Here's our first problem. You've reached mile 19 of a 26-mile race. I guess you'd call such a race an almost marathon. Not quite. There's a little smiley face over there. True marathon is something like about 26.2 miles, but I wanted to use integers here, whole numbers. Integers do include negative whole numbers as well, and 0. So I didn't quite make it a marathon, I made it an almost marathon. How much further do you need to go to finish the race? All right, I hope you can see what the answer is. Think a second. You're back. It's 7 miles is how much left you have to go. And how do you solve that? Well, you do a subtraction. 26 minus 19 is 7 miles. Then the units miles would go to each of the numbers there. That illustrates something about subtraction, that it's more than just taking away. You can think of subtraction in terms of how much more you have to add to. You've got to add 7 to 19 to get 26. That can be phrased like this. What should I add to 19 to get 26? Thought of another way, what question mark should be added to 19 to get 26 written like that as an equation? Question mark is what you're trying to find. Now you can find it in this example easy enough just by thinking about it to realize the question mark must represent the number 7, and well, I guess it's just a coincidence that it sort of looks like a 7. But in general, when you're trying to solve an equation like this, to try to figure out what the unknown is, this thing question mark, you want to, well, one way to think of it is to imagine subtracting 19 from both sides of this equation. On this side you get 7, 26 minus 19 is 7, and on this side 19 minus 19 is 0. In effect, these cancel out. Question mark plus 0 equals 7. 0 is the additive identity. 0 plus anything is the anything. 0 plus question mark is question mark. The unknown is 7 here. So you do subtraction to get the answer. The problem can be thought of as an addition problem where there's an unknown thing that you're trying to add to one side of the equation. The fact that this works is related to the fact that subtraction can be thought of as the inverse operation of addition. You could even say 26 minus 19 equals 7. You can give a reason for it based on addition, since 7 plus 19 equals 26. If you hadn't defined subtraction yet, well, this is how you would define it in this particular example. And in general, if we use symbols here, you could say, ready for this? A minus B equals C, since C plus B equals A, or B plus C equals A. You can always think of any addition, the subtraction problem, in terms of addition. Here the A, B, and C all represent numbers, and you can think of them as integers. Try plugging in any integer you want, even negative integers. This is going to work. In a similar way, division can be thought of as an inverse operation of multiplication. You make $11 an hour, say after taxes are taken out, and you're saving up all the money you make to buy a $583 computer after the taxes are added to the computer cost. So we're not worrying about taxes here, that's the point. How long will you need to work to pay for the computer? I have trouble seeing this whole thing here. All right, think about that for a second. See if you can figure out the answer on your own. Pause the video. Now if you're back, let's work it out. Hopefully you see that the answer is to do a division. 583 divided by 11 is going to give you the answer. And I'm going to do this in my head. How do I do this in my head? Well, I know 11 goes evenly into 55. 11 is a divisor of 55. It also would be a divisor of 550. Goes into 55 5 times, so it'll go into 550 50 times. 583 is 33 more than 50. I know 11 divides evenly into 33 as well, 3 times. So this answer is going to be 53, exactly, with a remainder of 0. The quotient will be 53 and the remainder will be 0. I won't even bother writing remainder 0 because this is exact as it is. So that's going to tell you that you're going to need to work 53 hours if you make $11 an hour to pay for a computer that costs $583. In words, you could phrase this one as, let's see, trying to be analogous to what we did before. What should I multiply, notice the word multiply, 11 by to get 583? In terms of an equation with an unknown represented by a question mark symbol, 11 times what, as a question mark, will equal 583? So the question mark up there is a regular question mark. The question mark here is representing the unknown answer. Well, I know the answer is going to be 53. Algebraically, what you can do to solve for question mark is you can divide both sides by 11. I'm writing as a fraction here. That is because fractions can be thought of as divisions. I'll talk about that in coming videos very shortly. The 11s cancel on that side. You're left with 583 divided by 11, which now I'll write as a division symbol, and that again turns out to be 53 hours. You can think of this multiplication in terms of units as well. This is $11 per hour times question mark hours, and the hours would cancel to give you $583. This allows us to then think of division in terms of multiplication. 583 divided by 11 equals 53 exactly, no remainder, since 11 times 53 equals 583. So if we know about multiplication, we can define division like this in terms of multiplication. We can give a reason for why this is true. That was really alluded to in the last couple of videos as well. In general, you can say that A divided by B is C, and I'm assuming here A, B, and C are integers, and that there's no remainder here. You know, in general, there could be a remainder, but I'm assuming no remainder here. And if that's true, if A divided by B is C, it would be true because B times C equals A, or C times B equals A. So there's a more general phrasing of this. You should think about these general formulas like this with more specific examples to help you understand it. But I'm going to stop right there.